How many particles of methane are in 102 grams of methane? The molar mass for methane is going to be 16.043 grams per mole. I'm going to first go ahead and translate this problem from English to math. How many particles will turn into X particles? CH4. Rn is my equal sign. 102 grams of methane is my number given. Then I'll look to see what kind of conversion factors I could possibly need. Currently I am in grams of methane, but I want particles of methane. The compound is the same, so I do not need mole to mole ratio. However, I do have a mass, so that means I do need molar mass. Molar mass was already provided as 16.043 grams per mole. I'm going to quickly turn that into a conversion factor. Okay, now I can get out of grams, which is my mass for methane, but that would only get me to moles, and I want particles. I need a conversion factor that will get me from moles to particles. That conversion factor is going to be Avogadro's number, which is definitional as 6.022 E23 particles per mole. So I'll quickly give that to myself as a conversion factor. That would allow me to get out of moles and into particles. So those are the only conversion factors that I need. Now I just need to plug them in appropriately. Currently, I have grams of methane in the numerator, which means I need to pick the version of the molar mass which has grams of methane in the denominator. That will be this second version here. And I'll go ahead and plug that in. Grams of methane would cancel, leaving me with moles of methane. I don't want moles, I want particles. So I'm going to go ahead and I'm going to pick the version of the conversion factor that allows me to cancel out moles. Moles is currently in a numerator, so I need the version that has moles in the denominator. That would be this first version here. Moles of methane will cancel, leaving me with particles of methane, which was the unit that I said that I wanted, so I can go ahead and plug that into the calculator. I'll plug that in using everything that is in the numerator being multiplied. And I'll be dividing by everything in the denominator. And I am left with 3.8287357 for E24. 102 has three significant figures, so I'm going to go ahead and I'm going to round it to that third sig fig. 2 would be the last number that I care about. 8 makes me round up, so this will turn into 83. Only English left in my math. The thing that I said that I wanted, particles of methane. There we go. My next problem states, how many particles of water are needed to produced when 5.4 moles of oxygen are consumed? So I have two different compounds here. I have water and I have oxygen. Since I have two different compounds, I know that I'm going to need a mole-to-mole ratio between the two. So I'm going to go ahead and give myself that. I'm going to take the coefficient in front of oxygen, just 2, insert the word mole, and then give myself the formula for the compound, O2. The coefficient in front of water is also 2. So I would give myself 2 and the word mole, and then compound formula for water. And then I would go ahead and flip it since it's a conversion factor and I don't know which version I'll need. Next, I will go ahead and see that I'm looking for particles of water. So that means I do need Avogadro's number. I only need Avogadro's number conversion for the unit, or for the compound that is attached to the unit particles. So I only need it for water. So 6.022 E23 particles water for every 1 mole of water, or for every 1 mole of water, 6.022 E23 particles of water. How many particles will turn into X particles of H2O means particles of water, H2O. Our produced one is my equals sign. Number given in the problem was 5.4 moles of oxygen. Currently I'm in moles of oxygen, and I want to get to particles of water. I am both in the wrong compound and in the wrong unit. Since moles is my current unit, that means I can go ahead and directly use the mole-to-mole ratio to get me to the correct compound. I just need the version of the conversion that has moles of oxygen in the denominator, as I currently have it in the numerator and would like it to cancel. That will be this bottom version here. Moles of oxygen would then cancel, and that would leave me with moles of water. I am currently in the correct compound. I'm in water now, but I'm not in the correct unit. I want particles, but I have moles. So that means I do need that of Avogadro's number conversion, and I need the version of the conversion that has moles of water in the denominator so that I can cancel that out. So that is going to be this top version here. Moles of water would cancel, leaving me with particles of water, which was the unit that I said that I wanted. So that means I can go ahead and move to solving this problem. I'm going to switch to having the calculator over here. I will be multiplying everything in the numerator, so that's 5.4 times 2 times 6.022 E23, and dividing by everything in the denominator. Which is 2 and 1. I just realized I made a mistake in the previous problem. I accidentally did not include the exponent, the E24. I accidentally dropped that. I did not mean to. Apparently I just got a little bit excited. So my bad. I apologize. It should have read 3.83 E24 particles of methane. Okay, completing this, I'm going to go ahead and plug that into the calculator. That'll give me 3.25188 E24. 5.4 only has 2 sig figs. 5 does make me round up, so 3.3 E24 particles of water. Okay, so this next problem states how many grams of sodium chloride are produced if 5.04 E31 particles of water are produced. So I see the unit grams, so that means I do need molar mass. Molar mass is already provided as 58.443 grams per mole. I'm just going to quickly turn that into a conversion factor. Okay, and I also see the unit particles, which means I do need Avogadro's number. I only need Avogadro's number for the compound that is attached to that, so that's going to be water. So I'm going to quickly turn that into a conversion factor as well. Okay, so I am now capable of getting out of grams of sodium chloride, or getting into grams, I should say, and converting out of particles. I currently have two different compounds, which means that I will need the multiple conversion factor between sodium chloride and water. Coefficients in front of each is 1. How many grams will turn into X grams sodium chloride are produced if is my equal sign, and then 5.04 E31 particles of water. Currently I am in particles of water, and I want grams of sodium chloride, so I'm not in the correct unit, nor am I in the correct compound. So I need to go ahead and convert out of particles of water first. So I'm going to pick the version of the conversion factor that allows me to cancel that. So that would be that bottom version there. Particles of water would cancel, leaving me with moles of water. I'm not in the correct unit, nor am I in the correct compound, but I am in something that will allow me to get to the correct compound. I'm going to need to use the multiple ratio between water and sodium chloride. Moles of water will cancel, leaving me with moles of sodium chloride. That is the correct compound, but it's not the correct unit. I want grams, not moles. So finally, I will need the molar mass of sodium chloride. Moles of sodium chloride will cancel, leaving me with grams of sodium chloride, which was the desired unit and compound. So that means that I can go ahead and finish my problem. So that would look like 5.04 E31 times 1 times 1 times 58.443. And this all will be divided by 6.022 E23, 1 and 1. Okay, that gives me the number. Ooh, very large. Okay, let's see. So that's 4,891,277,317. And 5.04 only has 3 sig figs, so 1, 2, 3. This 9 is the last number that I care about. 1 does not make me round up. So that would be 4,890,000,000 million. And add commas to help me make sure that I keep, there you go. Okay, only English left in my math is grams sodium chloride. Very, very large sample of sodium chloride there. Okay, so here we have the synthesis of water. It states how many particles of oxygen are needed to produce 5.63 E41 particles of water. So how many particles, X particles, oxygen are needed to produce my equals 5.63 E41 particles of water. Okay, so I have oxygen and I have water. Those are my two compounds of interest. I do have two of them, so that means I do need the mole-to-mole ratio. Coefficient in front of oxygen is 1, coefficient in front of water is 2. And then I can see particles for both, so I do need the Avogadro's number conversion for both of them. Okay, now that I have all of my necessary conversion factors, I can go ahead and start plugging things in. Currently I'm in particles of water, so I'm going to go ahead and pick the version of the conversion factor that allows me to cancel particles of water. It's going to be my first use of the Avogadro's number, and it's going to have moles of water on top. Particles of water will cancel, leaving me with moles of water. That's not the correct unit, nor is it the correct compound. I need to go ahead and cancel out moles of water and get me into moles of oxygen. So that would be this top version here. Moles of water will cancel, leaving me with moles of oxygen. Moles of oxygen is the correct compound, but it is not the correct unit, so I need to go ahead and convert out of moles and into particles. So this will be my second use of the Avogadro's number conversion factor. That will get me out of moles and into particles. Moles of oxygen will need to be on the bottom. Moles of oxygen will cancel, leaving me with particles of oxygen. You can do this one of two ways. You can either straightforward plug this into the calculator, or you can notice that I have the same number appearing at the top and at the bottom. That number is 6.022 times 10 to the 23rd. It appears twice because I had to convert from particles to particles. This number, just as if my units were appearing at the top and at the bottom, can cancel as they appear in two places, in the numerator and in the denominator, leaving me exclusively with 5.63 E41 times 1 divided by 2 and 1. If this makes you uncomfortable, 41. If this makes you uncomfortable, you can go ahead and still include both Avogadro numbers inside of your problem. This only happens if you're going from particles to particles. Okay. That will leave you with 2.815 E41. This had 3 sig figs, so 3 sig figs it is. 2.82 E41 particles of oxygen.